Hello there, my name's Charlie. I'm a forecaster here at the Met Office. Now, many of you will have seen pressure charts used on a TV broadcast or even on the back of a newspaper, and some of you will understand what the lines and the triangles and the different bits and pieces mean on there. But if not, I'm going to give you a step-by-step introduction to what us weather forecasters call synoptic charts. Now, the word synoptic simply means the current situation, and in weather terms, that means looking at the pressure pattern, the fronts, the wind speed and direction currently, and also seeing how they evolve over the coming few days. If we take a look at this map of the UK and the North Atlantic, you can see the pressure pattern there, and that'll be a familiar sight for many of you. It's important to know that pressure, wind and temperature are in constant balance throughout the atmosphere, but the atmosphere is always changing to try and maintain that balance. And for us in the UK, things are particularly changeable, and we tend to see quite variable weather as a result. Now, the pressure pattern will always show you a number of things. We'll always have areas of high pressure and areas of low pressure, and these white lines that circulate round show where the pressure is equal. They're called isobars. Now, air moves from areas of high pressure to area of low pressure to try and maintain that balance, or to try and ease that difference, and that's when we have air moving around and we feel wind moving. Sometimes, though, the pressure gradient, if you like, the difference between the high and the low pressure is much bigger, and so the air moves faster, and that's shown by tighter isobars that you can see to the north of the chart there. So we know something about the speed of the wind, but what about where it's coming from? Well, we know that air moves around areas of high pressure in a clockwise direction and in low pressure in an anti-clockwise direction. So now we know something about the speed of the wind and indeed where it's coming from. Now, these differences in pressure, temperature and wind circulating around the globe mean that there's different types of air, and by that I mean they have different characteristics, such as how cold or warm they are or how much moisture they're carrying. We need to mark out these differences somehow. So many of you will have seen this warm front. It's a red line with red semicircles, and also a cold front, which is a blue line with blue triangles. And these just mark out these differences between how cold and how warm and how moist the air mass is. And also importantly, we tend to see warmer air following a warm front and colder air following a cold front. And also we see increased amounts of cloud and rainfall in and around the area that the front marks. Another type of weather that you can spot on a weather chart lies between a warm and a cold front. That's what we call a warm sector. It's a fairly cloudy type of air mass, and it can bring mist and fog and also some outbreaks of patchy light rain from time to time. Now, in time as well, a cold front will tend to catch up with the warm front because it moves faster, and we end up with something called an occluded front. In time, those occlusions can form their own entities as well, but they're marked by a purple line with purple semicircles and purple triangles next to each other. Now, the direction in which these semicircles and triangles point simply marks out the direction of travel of the fronts. So we know that these set of fronts are moving from west to east in time. In time as well, this difference between the type of air, how warm, how cold, how moist it is, will tend to become less marked. And you may note that some fronts have a little gap, or maybe even a little cross marked in them. There's occlusions there to the east of the chart, show that this difference between the air is weakening. They're called frontalytic fronts. And sometimes you may also see a set of fronts which have the triangles and semicircles that are unshaded. And these are what we call upper fronts. They're the same as the fronts at the surface, but they mark differences in the air higher up in the atmosphere. Now, a final thing that we should mention are sometimes we see these black lines here, like the one across northern Italy, and these also mark out different types of air, but what we call unstable air. These troughs mark areas of air which is trying to move around quite a bit. It's quite turbulent. For example, warm air trying to move above colder air. And with that process, we tend to see showers, and some of them can be quite heavy. So a trough marks out a type of air where it's particularly unstable, and we see a lot of showers. So I hope that gives you an idea about one of the most fundamental tools that us forecasters use here at the Met Office. If you want any more information about forecasting and indeed the processes involved, then do visit www.metoffice.gov.uk.